discussed during last week the what is forces and the fundamental forces. We also discussed the contact and the non-contact force. So in contact force, we have the uh, force due to gravity. So it is the force exerted by the object to the surface. And in contact forces, we have the tension. Then we also have the force exerted by the surface to the object, is the normal force, and the applied force, and last is the frictional force, which has two types of friction, the static and the kinetic friction. So those are the forces that we have discussed last week, and we also discussed how to solve for the frictional force and the normal force if the object is on the or along horizontal surface. So today we will, as a continuation, so we will talk about first with um, the free body diagram. So the free body diagram is a sketch which represents all the external force acting on a object. So if we see a free body diagram, so these are external forces acting on a certain object. So it represents, so it is a sketch which represents every forces or external forces which is acting on the object. So for example, if we have a table on for example, if we have a book on a table, so the sketch or the free body diagram of this uh, book, so the free body diagram, so it is a sketch, the free body diagram of this book. So if this is the book which lies on a table, if the red line is the table, then the book is at the top of the table, or okay, so the book is on the top of the table. So the free body diagram, so to sketch all the external forces acting on the object. So the first we have the weight of the object or the force due to gravity. So the force due to gravity is the force exerted by the book to the surface. So the force exerted by the book to the surface or the force due to gravity. And as mentioned last meeting, the direction of the force due to gravity is directly downward. So the force due to gravity is equal to the weight of the object. So the force due to gravity, so that is the first external force acting on the object. And then we also have the normal force, okay, the normal force or the force exerted by the surface to the object. So that is the normal force, which is perpendicular to the surface. So if this is our surface or the table is our surface, then the normal force is perpendicular to the table. So that is our normal force. And as I have mentioned last meeting, if the normal force is directly opposite to the weight or to the force due to gravity, then the normal force is also equal to the force due to gravity. So if the normal force is directly opposite to the force due to gravity, then the normal force is equal to the force due to gravity. So since there are two surfaces colliding, which is the surface of the book and the surface of the table, then if the two surfaces collide with each other or slide with each other, then there is a friction or force due to friction or the frictional force acting on that particular object. So the force due to friction or the frictional force also present in this um, object. And since the book is at rest, then the frictional force is in, or the friction is static. Frictional force or the static friction since the object or the book is at rest. So this is an example of a free body diagram of an object or an example of a sketch of the external force acting on the book. So this is an example of a free body diagram. Okay, so I repeat, the normal force is only equal to the force due to gravity if the normal force is directly opposite to the force due to gravity. And that would happen if the surface is horizontal or it is parallel to the ground. So, how can we identify, okay, how can we identify the normal force or the value of our normal force if the surface is elevated? If there is an angle of elevation to the surface, then how can we identify the value of our normal force since the normal force is not exactly or not directly opposite to the force due to gravity? So this is an example of an elevated surface. So as you can see, the box is being pushed by the person to the surface which is elevated by angle theta. So this is angle theta. Angle theta is the angle of elevation of the surface from the ground. So if this is the case, then how can we identify the normal force since normal force in this case is not equal to the force due to gravity? So since normal force is not equal to the force due to gravity in this case, so how can we determine the value of our normal force? So since the normal force is only equal to the force which is directly opposite to the normal force. So to do that, first is we need to have a free body diagram or a sketch of the external force acting on this box. So if this is the surface, which and the box is being pushed at the surface which is elevated from the ground, and the angle of elevation is the angle theta. Okay, so the box is being pushed on the surface which is elevated from the ground, which has an angle of angle theta. So the force due to gravity or the weight of an object is directly downward to the ground. So the weight or the direction of the weight or the force due to gravity is downward. So this is our weight. So this is the weight or the force due to gravity acting on the uh, so the weight or the force due to gravity. So this is the force exerted by the box to the surface, and the direction of the force due to gravity is downward. So since the person is pushing the box, then there is an applied force to the box, and that is the F sub A, which has a direction of um, moves to the right. So since it moves to the right, that is the applied force acting on the box, which is the force applied to the box by pushing the box. So since we have force due to gravity by the weight of the object, then since force due to gravity is the force exerted by the box to the surface, then there is also an equal or opposite reaction. Okay, there is an equal and opposite reaction by the surface, and that is the force exerted by the surface to the box, which is our normal force. And the normal force is always perpendicular to the surface. Okay? So the normal force is perpendicular to the surface. That is the force exerted by the surface to the box or to the object. So that is the force exerted by the surface to the object. That is the normal force, which is perpendicular to the surface. Okay? Next, since there are two surfaces sliding with each other, which is the surface of the box and the surface of the surface where the box resides. So there is also an force. Uh, there is also a frictional force that is acting on the box. And take note, frictional force is directly opposite to the applied force. So since our applied force or the direction of our applied force is to the right, then the direction of our frictional force is going to the left. So take note, frictional force is is directly opposite to the applied force. So if the applied force is greater than the frictional force, then the box will move. But if the frictional force is greater or equal to the applied force, then the box will remain at rest. Okay, take note, if the applied force is greater than the frictional force, then the box will move. But if the frictional force is greater or equal to the applied force, then the box will remain at rest. So this is an example of a free body diagram of an object that is inclined or elevated from the ground, or the surface of the object is elevated from the ground. Okay, sir, you mentioned kanina that if this is the case, if the surface is elevated from the ground, then the normal force is not equal to the force due to gravity. So, paano namin malalaman ang value ni normal force if it is not equal to the force due to gravity? Okay, so, as I have mentioned kanina, the normal force is only equal the normal force is only equal to the force due to gravity if it is directly opposite to the force due to gravity. So if they are directly opposite, then they are equal. So if this is the case, since the force due to gravity is not directly opposite to the normal force, so sir, hindi pa siya directly opposite. So para mas makita natin that they are not directly opposite, then we will rotate this a little. So our free body diagram, so we will rotate our free body diagram a little. So to rotate this, so if this is the case, okay, so the normal force, then the frictional force, and the applied force going to the right. So since our weight, so since we rotate a little, so therefore the weight is now inclined. So if kanina, the frictional force, the normal force, and the applied force are the one who are inclined. So this time, since we rotate this a little, so now it is not exactly so the weight is now the one who is inclined, and the other forces are straight line. So okay, so if this is the case, how can we identify the value of our normal force? So to identify the value of our normal force, we need to solve for the value of the force that is directly opposite to the normal force. And what is that force? That force that is the force that is directly opposite to the normal force this time is the component of our weight, or the component of our force due to gravity. So what are these components? So this is the x and the y component. So W sub x is the x component of our weight, and W sub y is the y component of our weight. So since W sub y is directly opposite to the F sub n, then we can say that the normal force is equal to the W sub y, or the normal force is directly opposite to the y component of our weight. So sir, paano namin makukuha? How can we solve for the value of our W sub y? Then W sub y can be taken by trigonometric function. And the angle of inclination, okay, ito, the angle of inclination is equal to the angle on this. Okay, so it is equal to the angle from W to W sub y. So angle theta in this in the free body diagram is equal to the angle theta on the angle of inclination. So since W sub y is the adjacent side of our angle, then we will use the ka on the SOHCAHTOA, which is the cosine theta, is equal to the adjacent, which is our W sub y, divided by the hypotenuse, which is the W. So to solve for our W sub y, we will use cosine theta is equal to W sub y, since it is the adjacent side of our angle, divided by the hypotenuse side, which is the weight, or the W. So that is how we identify for our W sub y, or simply we can say that W sub y is equal to If we cross multiply this, then we can have cosine theta times double u. So we have cosine theta. So w sub y is equal to cosine theta times w. So to solve for our w sub y, we'll use cosine theta times the weight of the object. So that is the y component of our weight, which is equal to the normal force, okay, which is equal to the normal force. So that is how to identify for the value of our normal force if the surface where the object resides is elevated from the ground. For that, okay, before we proceed with some examples, okay, first let us uh, discuss first the Newton's law of motion. So I think you are familiar already with the Newton's laws of motion. So in the Newton's law of motion, we have three laws. So law one, which is the first law is the law of um, the first law. Okay, so in the Newton's law of motion, we have three laws. Okay, the first law is the law of inertia. The second is the law of acceleration. And then we have the law of interaction. So in the first law, the law of inertia states that an object in motion, okay, an object in motion will stay in motion unless there is an external force acts upon the object. So an object in motion will stay in motion unless an external force acts upon the object. So that is the first law of Newton, which is the law of inertia. Okay, so the law of inertia, in the law of inertia, it is the explanation why if there is a, for example, if you are riding on a, for example, if a person is riding on a vehicle, so if a person is riding on a vehicle, then a sudden brake, there is a sudden brake applied by the driver. So if the driver is applying a sudden brake to the vehicle, then the law of inertia is the explanation why um, you will remain moving even though a sudden brake is applied to the vehicle. So if you have uh, already experienced, okay, so if you have already experienced riding on a vehicle, then there is a sudden brake on the vehicle. So there is um, this is the explanation why you will feel that you are still moving, and because of the seat belt, then the seat belt is the external force that acts on you so that you will um, stop uh, you will stop on moving, or you will stop moving, and that external force is the seat belt which you attach to your body. Because if you did not attach seat belt, or you did not use seat belt while you are riding on a vehicle, then if the driver has applied a sudden brake, then you will stay in motion. Okay, so you will stay in motion since there is no external force that acts on your body, and since there is no external force that acts on your body, then you will stay in motion And if the vehicle has a sudden brake, then there is an external force on the vehicle, which is the force by the brake. So since you are the only one uh, who is that is stayed in motion, so that would cause an accident. So you will mababangga ka sa front ng vehicle, or worst case would you will hit the windshield, and that would cause an accident. So the law of inertia, the reason of the explanation of that is because of uh, the explanation, the best explanation is the law of inertia. So if an object is in motion, will stay in motion unless there is an external force acts upon the object. Okay, sir, what is the explanation why if we kick a ball in an open space, though there is no external force or another object that is acts upon the ball, so why does the ball still stop? So bakit kaya hihinto yung bola since there is no other object that could hit the ball or that could be the cause to stop the ball? So the explanation of that is because of the gravity or the force due to gravity and the frictional force of the surface. So even though the even though there is no external object that would cause the ball to stop in an open space, so because of the frictional force and the gravity or the force due to gravity, so it is the external force that acts on the object that would cause the object to stop. So if there is no friction or gravity, then an object in motion will remain in motion unless it will unless mababangga siya by another object. So that is the first law of motion, which is the law of inertia. Okay? Then we have the second law of motion, which is the law of acceleration. So in the law of acceleration, it states that when a force acts on an object, then it will cause the object to accelerate. So if there is an applied force, so an applied force to an object will cause the object to accelerate, or it will cause the object to move. So if there is a force acting on the object, then that is the cause of the object to move or to accelerate. That is the second law of motion, which is the law of acceleration. So if a force is acting on the object, then that force will cause the object to accelerate or to move. And the force of acceleration or the force applied to the object is directly proportional to the mass and also it is directly proportional to the acceleration of the object. So the force is directly proportional to the mass of the object and the acceleration of the object. So the greater the mass of the object, you need to have a greater acceleration. And to have a greater acceleration, you also need a greater greater force. So kung mas malaki yung force, mas mabilis rin yung acceleration. And if mas mabigat yung bagay, then you also need a much greater force. But the acceleration is inversely proportional to the mass of the object. Okay, I repeat, the acceleration of the object is inversely proportional to the mass of the object. So kung mas mabigat yung isang bagay, mas mabagal rin ang kanyang acceleration. So kung mas magaan yung isang bagay, mas mabilis rin yung kanyang acceleration. Because acceleration is inversely proportional to the mass of the object. So the equation of the second law of motion or the law of acceleration is force or the applied force is equal to the mass times acceleration. So to solve for the force needed to accelerate or to move an object, so we need to multiply the mass of the object and the constant acceleration of the object. And that is the second law of motion, which is the law of acceleration. And the third law, we have the law of interaction. So we have this third law during our last discussion or the past discussion. So in every action, there is an equal and opposite reaction. So in every action, there is an equal and opposite reaction. So an example of the law of interaction or the third law is the normal force and the force due to gravity. So the action is the force due to gravity. So the equal and opposite reaction is the normal force. So if an object is exerting force to the surface, so there is also an equal and opposite reaction of the surface, which is the force exerted by the surface to the object, and that is the normal force. So that is the third law of motion, which is the law of interaction. So these are the three laws of motion, which is the first, the law of inertia, the first law. The second law is the law of interaction, and the second law, the first law is the law of inertia. The second law is the law of acceleration, and the third law is the law of interaction. So these were the law of interaction by Newton or the Newton's law of motion. Okay, so for the first example, we have a block of wood has a mass of 8.23 kilogram that is lying on a rough surface. So what is the force exerted by the surface on the block? So that is for the letter A. And for letter B, what is the minimum horizontal force needed to overcome the force due to friction? Okay. So to draw for its free body diagram, okay, so if this is the surface, so since it is lying on a rough surface, so since it is not directly stated if it is in horizontal or not, so we assume that it is on a horizontal surface since there is no angle of inclination or angle of elevation stated on the problem. So since there is no angle of elevation stated on the problem, then we can assume that it is on the horizontal surface. And based also on the second question, what is the horizontal force needed? So we can say that it is on the horizontal surface. So if this is our horizontal surface, then we have a block of wood. So if this is the block of wood, okay, so what is the force exerted by the surface to the block? So first, we have the force due to gravity. Okay, the force due to gravity. So this is the first force or the force exerted by the block to the surface. And as I have mentioned, the force due to gravity is equal to the weight of the object. So the force due to gravity is directly downward. So the direction of the force due to the gravity is always downward. So this is our force due to gravity. So since we have a force due to gravity, then we also have an equal and opposite reaction by the surface to the block. So that is the force exerted by the surface to the block, and that is the normal force. So take note, normal force is perpendicular to the surface. So since this is our surface, then the normal force is perpendicular to the surface. And the normal force is the unknown on the letter A, the force exerted by the surface to the block. Okay, so since we have a normal force, so we also have, since there is the block is on the surface, so there are two surfaces sliding with each other, colliding each other. This is the surface of the block and the surface where the block resides. So there is also a frictional force acting on this box. So there is a frictional force acting on this block. And that frictional force, so since the wooden block is at rest, so since it is not moving, so the frictional force is in static. So the friction is static. So that's why the coefficient, our coefficient of static friction is equal to 0.20. So for letter B, what is the minimum horizontal force needed to overcome the force due to friction? So we need to find the value of our force due to friction so that we can have a minimum force needed to move this box. So ano kaya daw ang kailangan nating force to move this box? And that minimum force or minimum horizontal force is equal to the force due to friction. So to find the minimum force or minimum horizontal force, we need to solve for the value of our force due to friction, or the F sub F. And to solve for our frictional force, we will use the equation of the static friction. Okay, so first let us proceed first with the letter A, or the force exerted by the surface to the block. So ito yung block. So to solve for the normal force, since the normal force is directly opposite to the force due to gravity, then it is equal. They are both equal. It is also equal to the weight. So we will use the equation of the weight. Force weight, which is equal to the gravity. So this is gravity. This is not F. This is G. So gravity is equal to mass. So the weight is equal to gravity times the mass of the object. So if the mass of the object is equal to 8.23, then multiplied by the mass, which is 9.81. So if we multiply these two, we have 80.7363 kilograms. So since we only have three significant figures, so we round this to three significant figure, and that is equal to 80.7 kilograms. If the weight is equal to the force due to gravity and also equal to the normal force, so the normal force is now equal to 80.7 Newton. So Newton, since we are talking about the force, so the standard unit is Newton. So we have equal to 80.7 Newton. And that is the force exerted by the surface to the block. Okay, so that is for letter A. And for letter B, the minimum horizontal force needed. So using the equation of the static friction, so F sub F is equal to coefficient of static friction times the normal force. So since we have okay, to lessen the percent error, we will use the exact value of our normal force, which is 80.7363 Newton times the coefficient 0.20. So if we multiply, that is equal to 16.14726 Newton. So since the least number of significant figure is only two significant figure, so from 16.14, we round this to two significant figures. So the frictional force is equal to 16 Newton. So the minimum force needed, so the minimum horizontal force needed to move the block of wood is at least 16 Newton. And that is the applied force. Okay, the minimum force is needed to move is the applied force. So to move the object, we need at least or greater than 16 Newton. Okay, so that is for letter B, the max minimum force needed to overcome the force due to friction. Okay, so suppose you wish to pull a large box weighing, okay, take note of the word weighing, 55 kilogram up ramp that is inclined at 20.0 degree. So with the horizon to a loading dock platform. So if the mu sub S is equal to 0.2, what is the force exerted by the surface on the box? So same question kanina but different situation. And how hard do you need to pull to start the box from moving? So for letter A and letter B, okay, it has the same question with the example number 1, but this time it is only on different situation since the surface of the since the surface is elevated from the ground with an angle of 20.0 degree. So if this is the case, then the normal force is not equal to the weight or the force due to gravity. So to solve for our normal force, okay, first we need to find for the component of our weight. So the angle of elevation is 20.0 degree. So this is the weight, which is equal to 55 kilograms. So the normal force, so we also have an applied force. So the normal force, which is the unknown, the force exerted by the surface to the box. So since they are not directly opposite, so since the normal force is not directly opposite to the weight, then we need to solve for the force that is directly opposite to the normal force, and that is the y component of our weight. And to solve for weight, we will use the ka on the cosine function, which is the cosine is equal to adjacent over hypotenuse. And take note, the angle is equal to the angle of elevation, which is 20.0 degree. So to solve for our W sub y, cosine theta times f of g, or our the weight, so theta is equal to 20.0 and the force due to gravity is 55 Newton. So W sub y is equal to cosine 20.0 degree times 55 Newton, and that is equal to 51.68 3094.14 Newton. So since we only have two significant figure, so the least number of significant figure is 2. So we'll round this to two significant figures. So 51.68 round to two significant figure, that is equal to 52 newtons. So the force exerted by the surface to the box is equal to 52 newtons. So that is for letter A. And for letter B, we'll solve for the minimum force needed to move the box. So we need to solve for the frictional force. So since frictional force is the minimum force needed to pull the box. So if the applied force is going to the right, then the frictional force is going to the left. So to solve for our frictional force, we'll use F sub F is equal to mu sub S times F sub N. So since the value of our mu sub S is equal to 0.2 and the normal force is the exact, we will use the exact value of our normal force, which is equal to 51.68 3094.14 newtons. So ito yung value na lumabas sa calculator. So times 0.2. So that is equal to 10.33661 so on newton. So since we only have one significant figure, the least number is one significant figure, which is the mu sub S. So we round this to one significant figure, and that is equal to 10 newton. So the frictional force or the force due to friction is equal to 10 newton. So that is the minimum force needed to pull the box to move up the incline. So this is the minimum applied force needed to move the box towards or to move the box up to the incline. Then let's proceed with example number 3. Okay, the example number 3 is an example of a law of interaction, law of acceleration. So what force is needed or required to move, okay, what force is required to move a 50.0 kilogram sack of rice, to move a 50.0 kilogram sack at a constant acceleration of 1.5 meters per second. So using the equation on the law of acceleration, so force is equal to mass times acceleration. So the mass is equal to 50.0 kilogram and the acceleration is 1.5 meters per second square. So substitute. So 50.0 times 1.5, that is equal to 75 newton. So since the least number of significant figures, so we have 2, which is the number of significant figure of acceleration. So since 75 is already 2 significant figures, so the force needed or required is equal to 75 newton. So that is the force required to solve for the force required to move 50.0 kilogram of sack at a constant acceleration of 1.5 meters per second square. Okay, so next example we have also, this is also an example of the law of acceleration. So example number 4, a 110 kilogram train is moving at a 25 meters per second. So this is the mass of the train. Then we have the velocity. So since it is moving, so we have the velocity. So since this is the velocity of the object before acceleration, so this is our initial velocity along a rail. So what force is needed by Superman to stop the train. So to stop the train, so since we are talking about, since we mentioned, since we stop the train, so therefore, this is the velocity of the train after applying force. So this is the final velocity. Since it is, since we stop the train, then the velocity is now equal to 0. Then the time interval is 30 seconds. So since we have the value of our mass, but we do not have the value of our acceleration, then using the force is equal to mass times acceleration, we need to solve first for the value of our acceleration using the equation of acceleration. And that is equal to final velocity minus initial velocity divided by the time interval. So the final velocity is equal to 0. Then the initial is 25.5 meters per second and the time interval is 30 seconds. So 0 minus 25.5 divided by 30, that is equal to negative 0.8333 meters per second square. Sir, the acceleration is negative. So if we use this in our equation, mass times acceleration, then the answer is also negative. Okay. So I think I mentioned this uh, during our topic in the acceleration, that the sign in acceleration, the positive and negative sign of acceleration, is just an indicator if the acceleration or the velocity is increasing, or if there is an increase or in velocity, or there is a decrease in velocity. So if there is an increase in velocity, then we will have a positive um, acceleration. But if there is a decrease in velocity, which in this case from 25 to 0, which is stop, then the acceleration is negative. So since the sign of acceleration is just an indicator, then we will use the absolute value of our acceleration in the equation force is equal to mass times acceleration. And the absolute value, so we will kunin natin yung absolute value ng acceleration, which is a positive. So 833 times 110,500 kilogram. So if we multiply these two, we will have a value of 92,083.333 Newton. And that is our, so since we only have the least number of significant figure is only 3, which is the number of significant figure of our time, 30.06 seconds. So 3 significant figures, so we round this to 3 significant figure, and that is equal to 92,100 Newton. So the force needed to stop the bus at the train after 30 seconds is equal to 92,100 Newton.